Today I'm going to present and discuss our project, the household alarm system. In our household alarm system prototype, we are using one passive infrared motion detector. The sensor will be responsible for detecting the raw input of motion for further use and processing by the program/sketch. The number of sensors can be scaled to the customer's unique situation. So the larger the house, the more sensors the customer can use. This idea can be explored in our next sprint into further detail. Regarding the think aspect, the program checks if there is any movement. If yes, then checks for typing. If not, it sounds the alarm. If typing authorizes the user's password, then either temporarily disables the alarm, if correct, or keeps beeping if the alarm is wrong. This can be followed from the graph. Is motion detected? No, it does nothing. Yes, it enables the alarm. The act is, if the motion is detected from the passive infrared sensor, enable the alarm and sound the buzzer. If the correct password is entered, this disables the alarm. The way the system acts currently can also be changed and improved upon in Sprint 2. However, we are happy for this at the moment how it acts, when the alarm is sound. The sensor that was used in our solution was a passive infrared motion detector. A digital signal was collected from the sensor and was used to determine if the alarm should sound. Another sensor used was a 16-digit number pad to accept a user-entered code. This code was compared to the original code entered by the user too. You can think of it as like this. When the owner or user leaves the house, they will enter a code from the keypad. This will activate the alarm system and engage the sensors. A 1-minute delay will be given to the user to leave the house. This is done in case and to prevent the accidental engagement of the alarm. When the user arrives back home and the alarm sounds due to motion, the same code entered previously will have to be entered again. The user story points are as follows. User story 1. As a homeowner, I want a motion detector installed for my property so that I'm aware of any unwanted intruders. If one story point is to equal 0.5 engineering hours, user story 1 will take 5 story points to complete. The features for user 1 story are transparency, safety, and awareness of the household in the form of intrusion and indication. User story 2. As a homeowner, I want an audible alarm so that I can hear and deter any unwanted intruders. User story 2 will take 14 story points to complete. The features for user story 2 are security, safety, and increased awareness in the form of audible notification from the alarm system. In the next clip that is about to be shown, you will see a quick demonstration on how our model for the Sprint 1 works. Above is also the link to the GitHub code that was written by Hussein and the other group members.
So this is going to be the project demo. This is the hardware setup. Here we have the Arduino, and then here's the PIR sensor we're going to use to sense people movement. Here's the keypad we use to enter a password, and here's the buzzer we have. And then there's a breadboard connecting all of it. So we'll float it. Okay, it's uploaded, and then here you can see on the screen, it detected movement quite soon. So the alarm's ringing because it got detected movement. So you need to enter a passcode. The first time you do it, you need to set a password. So you press 16 to enter numbers, and until you hear the sound, because keypad's quite bad. Yeah, there we go. So you enter 1, 2, 3, 4, 5, 6, 7, 8. 8-digit password. So there we go. You entered an 8-digit password and it works. Right, so right now the alarm is disabled for about 10 seconds. Yep. So it's detecting motion again till we make movement. Yeah. So now you need to enter a password. This time it needs to be correct for the alarm to be disabled. So let's try it out.
All group members were equally working on the sprint and contributed in different ways to work collaboratively to complete the task. This is the breakdown of the contribution by each team member. Rhys generated ideas, assisted in presentation and design, provided information for presentation and design. Anthony assisted in development and helped provide information for the presentation and design. Zach assisted Hussein in development, helped with design of presentation. Hasnain wrote the code in C and helped develop the project. As you can see from our Trello board, consists of mostly completed tasks such as writing the code for the motion sensor, buzzer, and keypad. This also includes debugging and optimization of the code to work effectively. The tasks such as define the sense, think, act paradigm were also completed for the presentation. Assigning burn down and user stories were also achieved in order to help the group members to stay on track throughout the completion of Sprint 1. Lastly, the hardware was built and tested with the code. And in our backlog, as you can see, are the list of tasks that need to be completed for Sprint 2. In the following slide, you can see how the burn down chart was assigned. Each day was given 3 hours to work this task from the beginning of the project. We fell short earlier on, however we worked on the task more often and more consistently when the Sprint 1 due date approached. Here are some photographic images of our hardware setup. Cleaning and refining this is one of our major goals for Sprint 2, for this to become a more clean and efficient setup. As you can see, the Arduino board is connected to the breadboard. This breadboard connects all the other motion sensors and input devices back to the Arduino board. More devices will be added to the next sprint to make this a more well-rounded device. Challenges faced during the sprint were plenty, mainly being due to the code and the hardware. Most tutorials and libraries were not compatible with the number pad we had, so code had to be developed from scratch for this setup. The number pad needed to be constantly polled to check what was being pressed in order to get a value. This resulted in having the same number multiple times if the user wasn't fast enough in pressing the keys. This created some issues in developing our code and hardware. We had to work around this to ensure that we could minimize this issue as much as possible. In Sprint 2, we will further develop these bugs and issues to make the system more well-rounded. Our future plans for Sprint 2 include the following. Our team wants to encapsulate the Arduino board and the sensors into something that looks like a more modern system. This can be done by 3D printing a box and placing the pieces inside to make the design more neat. We want to incorporate an 8-digit panel which the user will be able to see when entering the digit code. We would also like to incorporate an RFID system. So instead of entering the code, the user has the option of waving a pass card to set up and disarm the alarm. And lastly, we want to overall increase the efficiencies and the effectiveness of the system so the user experience will be greater. These are the main points we would like to focus on in the next sprint. I hope you enjoyed our demonstration for the first sprint. We look forward to extending our product and assembling a better and more well-refined device for our future sprint.